Hey everybody, here are the notes for homework number 19, solving trig equations, which is most of it, and also graphing the tangent function, which is a small part at the end. All right, let's see, make some weird shadows here. Hopefully that's not, hold on, should I turn off my light? No, that's worse. We'll stick with that. Hopefully it'll be fairly visible. All right, so let's just jump right in. Want to solve the equation 2 times sine of x minus 1 equals 0. Also, for all these problems, we're going to be limiting ourselves to x being bigger than or equal to 0 and less than 2 pi. So basically within one full revolution of the unit circle. So we only want angles between 0 and 2 pi. We don't want anything bigger than 2 pi or negative as an answer. So solving 2 sine of x minus 1 equal to 0, typically, if we only have one trig function, we start by trying to isolate it. So I'm going to rewrite this as 2 times sine of x equal to 1, and then divide both sides by 2 to get sine of x equal to 1/2. So now I have to think about what angle gets me a value of 1/2 for sine. Well, you can use a unit of a triangle. I look at this triangle over here, for example, this one here, my 30, 60, 90 triangle, I can see that looking at this angle here, the opposite over the hypotenuse is 1/2. So sine of pi over 6 is equal to 1/2. Great. So we know that one answer, really what we should be saying here is that our reference angle is pi over 6. We want sine to be positive. So we know that we're looking for answers in, well, the first quadrant where all trig functions are positive, and the second quadrant where sine is positive. So I want a reference angle of pi over 6 in the first quadrant, which is just pi over 6, and a reference angle of pi over 6 in the second quadrant. So in quadrant 1, my angle is going to look like just pi over 6. Cool. In quadrant 2, my reference angle is going to be pi over 6. So this angle here, if that reference angle is pi over 6, and we know that going halfway around gets you to pi, then my actual angle was pi minus pi over 6, which is 5 pi over 6. Or you could just know that in quadrant 2, the angle 5 pi over 6 is a reference angle of pi over 6. So in this case, our answers, there's two of them. It's x equal to pi over 6 and x equal to 5 pi over 6. Cool. Let's keep it going. So really, I should stop for a second here. That the basic idea is to isolate your trig function, figure out the correct angle that gives you the value you're looking for. So we know that sine of pi over 6 is equal to 1/2, and then find all the other angles in the appropriate quadrants that have the same reference angle, and those are your answers. So here, our reference angle of pi over 6 led to an answer of pi over 6 in quadrant 1, and 5 pi over 6, whose reference angle is pi over 6 in quadrant 2. Well, let's do this next question. Cosine squared x equal to 1/4. So if we're going to solve this, we're going to start by taking the square root of both sides. So that's going to give us cosine of x equal to plus or minus the square root of 1/4. But the plus or minus square root of 1/4, well, you can break up a square root as the square root of the top over the square root of the bottom. The square root of 1 is 1. The square root of 4 is 2. So looking for cosine is equal to plus or minus 1/2. Now again, it's probably worth memorizing these, but you can also still look back at your triangles. If you look back at this again, this 30, 60, 90 triangle, we can say that cosine of pi over 3 is going to be adjacent over hypotenuse. So cosine of pi over 3 is 1/2. So our reference angle here is pi over 3. And again, just as a reminder, our answers need to be between 0 and 2 pi. So reference angle is pi over 3, but I want cosine to be positive or negative 1/2. So that means I'm actually getting an answer in every quadrant, because in quadrants 1 and 4, cosine is positive, and in quadrants 2 and 3, cosine is negative. So these ones are going to be the ones where cosine of x is equal to positive 1/2, And these two are going to be where cosine of x is equal to -1/2. In either case, the reference angle is pi/3, right? I wrote that over here. So basically, in every quadrant, we're looking for the angle whose reference angle is pi/3. So in quadrant 1, it is just pi/3. Right, it looks like that. Pi/3. In quadrant 2, it's going to look like that. Again, the reference angle is pi/3. And the actual angle here is 2 pi/3. And then in quadrant 3, I can put that over here. In quadrant 3, right, we're going all the way to here. And that reference angle is pi/3. So our actual angle is pi plus pi/3, which is 4 pi/3. And then finally in quadrant 4, we're going to get all the way to over here where the reference angle right there is pi/3. So the actual angle, well, we go all the way to 2 pi and subtract pi/3. The actual angle is 5 pi/3. So here we get 4 answers, 1 in each quadrant, all with the same reference angle of pi/3. So our answers would be x equal to pi/3, 2 pi/3, 4 pi/3, and 5 pi/3. I don't love my next question, but all right, fine. The reason I don't love my next question is because it's actually going to have the same exact answer, which is not very exciting. So I'm actually going to change it up. Let's make it, instead of sine squared of x equal to 3/4. So the reason this would have the same answers is because if you take the square root of both sides, you get sine of x equal to plus or minus √3/2. And that's exactly having a reference angle of also pi/3, because sine of pi/3 is opposite of our hypotenuse, which is √3/2. So let's make it a question that has different answers. Let's say we have sine squared of x equal to, instead of 3/4, let's make it a 1/2. A little more interesting. So let's take the square root of both sides. That's going to lead us to sine of x equal to plus or minus the square root of 1/2. But again, we can break that up as the square root of 1 or the square root of 2, and the square root of 1 is just 1. So it's going to be 1 over the square root of 2. Again, either remembering which angle that is, we're looking at our triangle, we know that sine of pi/4 is equal to 1 over √2. So our reference angle here is pi/4. Right, and if you look back at our triangles here, oh yeah, sine of pi/4 is the opposite of our hypotenuse, which is 1 over √2. Cool. So now we're looking for well, in fact, let's talk about the quadrants here. So since sine can be positive or negative, we want positive in the first 2 quadrants, negative in the last 2 quadrants. We want an answer in every quadrant. Okay. So we can just kind of draw them out, right? We want this angle with that reference angle pi/4, this angle with that reference angle pi/4, this angle with that reference angle pi/4, and this angle with that reference angle pi/4. So we want, essentially in quadrant 1, the angle should be pi/4. In quadrant 2, the angle should be pi minus pi/4, which is 3 pi/4. In quadrant 3, the angle should be, I feel like I've been saying reference angle. I should be saying angle, sorry. In quadrant 1, the angle is pi/4. In quadrant 2, the angle is pi minus the reference angle, which is 3 pi/4. In quadrant 3, the angle is pi plus the reference angle of pi/4, which is 5 pi/4. And finally, in quadrant 4, the angle is all the way around and then subtract pi/4. So it's going to be 2 pi minus pi/4, which is 8 pi/4 minus 1 pi/4, which is 7 pi/4. So again, we get 4 answers, and our answers are pi/4, I should say x equals pi/4, 3 pi over 4, 5 pi over 4, 7 pi over 4. And so for sine or cosine equal to either 1/2 or 1 over root 2 or root 3 over 2, this is typically kind of the way we do it, is we look for the reference angle and then we look for which quadrants have the right angles for having the right sign, plus or minus. Same with truth will be true. We'll see a tangent one in the future here a little bit. Well, let's look at something a little more complicated. So here we have a cosine squared x minus cosine x equal to 0. And I would say the first thing we want to do here actually is factor. So from this, we can factor out a cosine x. So cosine x times cosine x minus 1 equal to 0. So here, we either are going to get cosine of x equal to 0. Here, we're going to get cosine of x equal to 1. Now, these aren't values that come from special triangles. I like to think of these as values that show up on the unit circle, but I was watching Grant's video, he likes to kind of think of it as values you see on the graphs of sine and cosine. So either way, let's take a look. So for the graph of cosine over here, you can see that, okay, well, cosine is equal to 0 at pi over 2 and at 3 pi over 2. Whereas, so let's actually write that down. So cosine of x is equal to 0 when the angle x is pi over 2 or 3 pi over 2. Whereas cosine of x is equal to 1 at, oh, I didn't label this right, that's a 1 there. It's a 1 there. At 0 and 2 pi, but I'll point out again, our angles, we've been saying that x is between 0 and 2 pi, but we've been writing that x is strictly less than 2 pi, so it means we shouldn't actually include 2 pi as a potential answer. So here, trying to find cosine x equal to 1, we're just going to say x is equal to 0. That's not my preference of how to do it, but it's a way to do it. I would probably do it by saying, oh, if cosine is 0, I'm going to look on the unit circle and be like, well, great, cosine is 0 here at pi over 2 and down here at 3 pi over 2, because that's where the x coordinate of the unit circle is 0. And then cosine is equal to 1 when the angle is 0. So cosine of 0 is equal to 1 right there. Either way is fine, depends on how you like to think of it. So then writing our answers, we get x equal, if we write them in increasing order, because that's kind of how the homework is asking us to do it, x would be 0, pi over 2, or 3 pi over 2. But we would not include 2 pi as an answer, even though it feels like we should. Some more examples. 2 sine squared x minus sine x equal to 1. So we're first going to rewrite this as 2 sine squared x minus sine x minus 1 equal to 0. The second one we can do is called the u substitution, where we can let u equal sine of x. So if u is equal to sine of x, and u squared is equal to sine squared of x, we can rewrite this as 2u squared minus u minus 1 equals 0. This does factor. It factors as 2u with something and u with something. So I know I want to have, let's see, I think I want to have a, well, these both need to be some sort of 1, either a minus 1 and a positive 1. I think I want a plus 1 here and a minus 1 here. So when you multiply it out, you get 2u times u is 2u squared. 2u times negative 1 is negative 2u. And plus 1 unified, look at that right here. So that's a plus u, and that's a minus 2u. That adds up to negative u. And then 1 times negative 1 is negative 1. So it looks like it worked out all right. So then what that gives us here is either, let's go this way over here. I'm going to get 2u plus 1 equal to 0, or u minus 1 equal to 0. Let's isolate the u's. That's going to be u equal to negative 1/2, or u equal to 1. But then we should remember that u is really equal to sine. So we're really saying sine of x equal to negative 1/2, or sine of x equal to 1. And for sine of x equal to positive 1/2, that's going to be my 30, 60, 90 triangle. And specifically, I want the pi over 3 angle, because sine of pi over 3 is the, oh, nope, sorry. I want the pi over 6 angle, because sine of pi over 6 is opposite of our hypotenuse, which is 1/2. So here, my reference angle is pi/6. And then the quadrants I want, well, since I want sine to be negative, I don't want quadrant 1 or quadrant 2, I want quadrant 3 and quadrant 4. So I want a reference angle of pi/6 in quadrant 3, and a reference angle of pi/6 in quadrant 4. So that's going to lead me to pi plus pi/6, which is 7 pi/6. I'm going to get pi plus pi/6, which is 7 pi/6. And then all the way around, but then minus pi/6, so 2 pi minus pi/6, which is 11 pi/6. To solve sine of x is equal to 1, that's where I would use the 4 points I'm in the circle. So if I want sine to equal 1, well, I know that I want the y-coordinate to be 1, which is right there, so my angle should be pi/2. So to solve sine of x equal to 1, it's going to be x equal to pi/2. So then if I was going to write out my answers in increasing order, I'd say that my answers are x equals either pi/2, that's the smallest, then 7 pi/6, then 11 pi/6. Sometimes there's some quadratic factoring that has to happen there, and then you get kind of two pieces if we set each of those equal to 0. All right, more. So here, again, most of these problems, if they're not equal to 0 already, we should set them equal to 0. So the first step I should make is to rewrite this as the square root of 2 times sine of x times cosine of x minus sine of x equal to 0. And then factor out a sine of x. I'm left with a root 2 cosine of x minus 1 equal to 0. So either 1, sine of x equals 0, or 2, the square root of 2 times cosine x minus 1 equals 0. Which we can rewrite as the root 2 times cosine x equals 1, or cosine x equals 1 over root 2. Or if you prefer, root 2 over 2. So for here, for sine of x equal to 0, again, we know that's one of our quadrantal angles, or angles that's on an axis. I look over here, sine is 0 when the y-coordinate is 0, so either at 0 radians or at pi radians. We're not going to go all the way around to 2 pi radians. Or you could look at the graph here, right? Sine is 0 when the angle is 0 or when the angle is pi. And again, we're not going to go all the way to 2 pi. So sine of x is equal to 0 when x is 0 or pi. Cosine of x equals 1 over root 2. Well, we know that comes from a 45, 45, 90 triangle, or a pi/4, pi/4, pi/2 triangle. Cosine is adjacent over hypotenuse, so yeah, the reference angle is pi/4. But we want cosine to be positive 1 over root 2, so we want first quadrant or the fourth quadrant, not these second and third quadrants. So we want in the first quadrant. So if your angle is in the first quadrant and it's not like more than 2 pi, it's just whatever the reference angle is. So in the first quadrant, if your reference angle is pi/4, your angle is pi/4. And in fact, I forgot to write down the reference angle is pi/4. So in quadrant 1, that's just going to be pi/4. In quadrant 4, it's going to be your full 2 pi minus pi/4. So 2 pi minus pi/4. That's 8 pi/4 minus 1 pi/4, which is 7 pi/4. So there's your 3 answers. Sorry, your 4 answers. And just something, sorry, we'll finish up. So then writing these out in order, we say that x is 0, pi/4, pi, 7 pi/4. Those would be our answers written in ascending order. Just as a point of interest, I'll remind you that once we've got the reference angle, we know the quadrant. Well, if it's quadrant 1, it's just the angle. If it's quadrant 2, it's pi minus your reference angle. Quadrant 3, it's pi plus your reference angle. If it's quadrant 4, it's 2 pi minus reference angle. It's always how it works. Look at the next page here. tangent squared x plus tangent x equals 0. So again, looks like we have some factoring to do. So I'm going to factor out the tangent. So tangent of x times tangent of x plus 1 equal to 0. So one of these does come from a triangle. That's specifically this part here. So here we're going to get tangent of x equal to 0. Over here, we're going to get tangent of x plus 1 equal to 0, which becomes tangent of x equals -1. Well, again, from our little triangles here, we know that tangent, which is opposite over adjacent, is equal to 1 over 1 when the angle is pi over 4. So we know that tangent of pi over 4 is +1. So tangent of pi over 4 is +1. In other words, our reference angle here is pi over 4. So tangent is negative. Well, let's see, all students take calculus. Not here, right? It's positive here and it's positive here. So we want second quadrant and the fourth quadrant. The angle, the reference angle is pi over 4. So again, we're going to do a reference angle pi over 4 here, which just means we're going to do pi minus pi over 4. So in quadrant 2, we're going to get pi minus pi over 4, which is 3 pi over 4. And then in quadrant 4, we're going to get 2 pi minus our reference angle of pi over 4. So 2 pi minus pi over 4 is 7 pi over 4. Over here, tangent equals to 0. That's not one of those triangles. That's where you have to use what I think of as the corners of the unit circle. So I want tangent to be 0. That's going to be an angle of 0 or at pi. Same as for sine, actually. So here's our 4 angles, 0, pi, 3 pi over 4, and 7 pi over 4. Written in order, our answer is 0, pi over 4, pi, sorry, not pi, 0, not pi over 4, sorry, pi over 4 was not correct, sorry, 0, 3 pi over 4 is the next one, then pi is a little bigger, then 7 pi over 4. Let's look at the next one. Cosine x equal to secant of x. So what I would probably do here first is rewrite secant of x as 1 over cosine. And then I would multiply both sides by cosine. So that cosine times cosine, which is cosine squared x, equals 1. But if cosine squared equals 1, that means that cosine of x equals plus or minus the square root of 1, which is just plus or minus 1. Which makes sense if you think about it, right? If cosine was equal to 1, well, then you'd have 1 here, and 1 over 1 is 1. If cosine was equal to -1, you'd have -1 here, and 1 over -1 is also -1. So both of these totally make sense as values that cosine of x should equal. So I'll find the angle, though. So if cosine is plus or minus 1, well, let's look at the little unit circle here. Cosine is equal to 1 when the angle is 0. Cosine is equal to -1 when the angle is pi. And again, we don't go all the way around to 2 pi. So again, for angles, they're between 0 and strictly less than 2 pi. Our answers are going to be 0 and pi. I feel like I skip a page somehow. No, those pages were out of order. Sorry about that. It's not that big a deal, but not what I meant. So let's look at this one here, which is another example. Oh, this page. Okay, I see that. I see. It wasn't that it was out of order. That page was just trash. No, we've been in order. We're good. Okay. Okay, let's look at this last one here. So this again looks like an example of sort of the doing a u substitution or some quadratic factoring. So you've got essentially a u squared minus 3u plus 2 equals 0. That's going to factor as u minus 2 times u minus 1 equals 0. So we're going to end up getting u equal to 2, which means cosecant is equal to 2, or u equal to 1, which means cosecant of x is equal to 1. I'm not good at remembering what cosecant and secant, or sorry, cosecant is equal to. So what I like to do is I know that cosecant is the reciprocal of sine. So if cosecant of x is equal to 2, then sine of x has to equal 1/2. And if cosecant of x is equal to 1, then sine of x equals 1 over 1, which is still 1. So great, sine of x equals 1/2. I think that's the first problem we started with, actually. But let's do it anyway. So sine of x equal to 1/2. Sine of pi over 6 is 1/2, so the angle is pi over 6. So my reference angle is pi over 6. I know I want to be in the first quadrant, in the second quadrant. So we want, in the first quadrant, the angle is going to be pi over 6. In the second quadrant, it's going to be pi minus pi over 6. So we're going to get pi over 6, and pi minus pi over 6 is 5 pi over 6. For sine of x equal 1, we have to look at the circle thing. For sine to be 1, it's going to be right there where the angle is pi over 2. So our angles written in order would be x equal to pi over 6 is the smallest, then pi over 2 is the next smallest, then 5 pi over 6 is the next. All right, one more, and then we'll graph some tangent, which is not too terrible. So this one looks kind of funky. We've got sine squared x plus 3 cosine x plus 3 equals 0. You got sines and cosines. It's a little weird. In this one, we want to use a trig identity for sine squared. So we're going to rewrite this as 1 minus cosine squared x plus 3 cosine x plus 3 equals 0. And then I'm going to add 1 to the derivative, so I have a negative cosine squared x plus 3 cosine x minus 3 equals 0. I know I'm going to do a u substitution here like I did in the previous problem. I'm going to let u equal cosine, so I have u squared, negative u squared plus 3u minus 3 equals 0. So that's a plus 3. But I'd really rather not have a negative u squared, so I'm going to multiply both sides by -1 to get positive cosine squared x minus 3 cosine x minus 1 plus 3 is 4. Sorry about that. Minus 4 equals 0. Let me just double check that again. I replaced 1 minus sine squared with 1 minus cosine squared. And then I rewrote this as just negative cosine squared plus 3 cosine x, and the 1 plus 3 became a 4. And then I multiply both sides by -1 to get positive cosine squared x minus 3 cosine x minus 4 equal to 0. Cool. Now we're going to do a u sub. So we're going to rewrite this as u squared minus 3u minus 4 equal to 0. So we're letting u equal cosine x. Great, that factors. It factors as u minus 4 times u plus 1 equal to 0. So then we're going to either get u equal to 4, which becomes cosine of x equal to 4, or u equal to -1, which becomes cosine of x equal to -1. Cosine x equal to -1, we know there's an answer to that. It is believe, let's see, not here, but here, where the angle is pi. Cosine x equal to 4. Well, either way, whoops. Whether you look at the unit circle, you see, well, the biggest cosine can be is 1 because the furthest right the circle goes is 1. Or you look at the graph where the graph goes no higher than 1, right? It keeps just staying at 1 and then, right, the whole thing again and again and again. The biggest cosine of x can never be is 1. In fact, it would be correct to say that cosine of x is always between 1 and -1. So is sine of x. What it means is this has no solution. So the only solution to this equation is x equal to pi. Sometimes that'll happen where you'll have sine of x equal to 2 or cosine x equal to -5, and that part just won't have a solution. All right, let's look at the last part of this, which is graphing tangent. Graphing tangent isn't too terrible, but we'll start off by making a little table. The typical period, so I'll say tangent of x has a usual period of just pi. So unlike sine and cosine, its period isn't normally 2 pi, its period is normally pi. It repeats every pi. And the usual kind of period we like to draw for tangent isn't from 0 to pi, but from -pi/2 to pi/2. So we're actually going to start with these values here. And I'll remind you of our little card here. So let's start with the angles in quadrant 1 here. So tangent of pi over 6 is going to be 1 over root 3, which is root 3 over 3, which is about like 0.6. I think, yeah, that's about right, about 0.6. Tangent of pi over 4 is 1, right? It's 1 over 1. Tangent of pi over 3 is root 3 over 1. And root 3 is about 1.7. And then tangent of pi over 2 is, well, that's interesting. Tangent is 0. If we look over here at the unit circle part here, tangent of 0 is 0 over 1, which is 0. The tangent of, tangent of pi over 2 is 1 over 0. Make that 1 a little bit bigger there. 1 over 0, which is undefined. So tangent of pi over 2 is undefined. And what we're going to see is that as the angles get closer and closer to pi over 2, well, what's happening here is if your angles get closer to pi over 2, your x value is getting closer and closer to 0, and your y value is getting closer and closer to 1. So you've essentially got a fraction where the denominator is getting really, really small, the numerator is getting closer and closer to 1. If you divide 1 by a really, really small number close to 0, it's going to get really, really large. So what's happening here is that as the angle is close to pi over 2, this is actually going to get infinitely large. And we'll see this in the graph in a minute. On the other side, well, negative pi over 6 is in quadrant 4, right? If you go clockwise, right, negative pi over 6 is just that angle right there. In quadrant 4, tangent is negative. So we know that just like tangent of pi over 6 is root 3 over 3, tangent of negative pi over 6 is negative root 3 over 3, which is approximately negative 0.6. And tangent of negative pi over 4, still in quadrant 4, it's going to be negative 1. The tangent of negative pi over 3 is going to be negative root 3. And tangent of negative pi over 2 is going to get more and more and more negative. It's going to be undefined, but it's going to go in the negative infinity direction. All right, let's graph it. So I would like to focus on pi over 4. So pi over 4 is a little smaller than 1, right? Pi is about 3, kind of. Pi over 4 is about 0.75. So this number is not quite 1. So if I go like this, 1's like maybe like right there. So there's 1. There's negative 1. So tangent of pi over 4 is 1. Tangent of pi over 6, which is about right there, is like 0.6, right there. And tangent of pi over 3, which is about right there, is about 1.7. So like maybe like that. And then tangent of 0 is 0. So the right-hand side of this graph looks like this. Getting bigger and bigger and bigger, and it just keeps getting bigger and bigger and bigger. And the left-hand side looks like the kind of mirror image but rotated around. That's one period of tangent. And then it would repeat itself. So if you drew it again over here, there'd be another vertical asymptote over at like 3 pi over 2, and we do the same thing. Like that. Same thing to the left. It would repeat like that forever and ever and ever. It's kind of a great graph. When I'm graphing it, I'm really focused on the pi over 4 and the negative pi over 4, which give you values of 1 and negative 1, and then the vertical asymptotes at pi over 2 and negative pi over 2. Okay. We'll graph one more version of this. So we don't really do a lot of vertical stretching or shifting with tangent, but we do like to do some horizontal stretching or some changing of the period. So here, just like how y equals sine of x, the period is 2 pi, and for y equals sine of some multiple of x, like, I don't know, 5x, the period is 2 pi divided by 5. Same deal is true here. For the regular graph of tangent of x, the period is pi. For any other, the period is going to equal pi divided by that coefficient of x. So the length is pi over 3. What that usually means is, just like in the previous example, we cut our period of pi and basically went half a pi in one direction, half a pi in the other direction. We're going to do the same thing down here. We're going to cut this in half. So half a period is 1/2 times pi over 3, which is pi over 6. And the means for us is we're going to go pi over 6 to the right and left of the origin. And that's where we're going to get our vertical asymptotes. Another way to think about this is making a table again. Right? If I make a table, I'm really just kind of focused on the angles being, I don't really care about the pi over, like here, I don't really care about the pi over 6 and the pi over 3. I really just care about the 0, the pi over 4, the pi over 2, the negative pi over 4, and the negative pi over 2. I want those same angles to occur over here. So I want pi over 2, pi over 4, 0, negative pi over 4, negative pi over 2. And I know that if that's what my angle is, tangent of that angle, well, tangent pi over 2 is undefined, tangent pi over 4 is 1, tangent 0 is 0, tangent negative pi over 4 is -1, tangent negative pi over 2 is also undefined. But then to get back to my original x value, well, 3x divided by 3 is x. So pi over 2 divided by 3 is pi over 2 times 1/3, and pi over 2 times 1/3 is pi over 6. And pi over 4 times 1/3 is pi over 12. And 0 times 1/3 is 0. And it's going to be negative pi over 12. And negative pi over 6. So not surprisingly, my asymptotes are at pi over 6 and negative pi over 6. And then my 1 values are at halfway between. Here's my pi over 12. Here's my negative pi over 12. And then I don't exaggerate this too much, but like my 1's going to be right about there. So there's like 1, there's like -1. At that point there at positive pi over 12, comma positive 1. And this point here at negative pi over 12, comma -1. Kind of like that. Again, you shouldn't spend too much time graphing tangent, but here is one period of y equal to tangent of 3x. All right, that is all there is for the new material that's on homework number 19. After that, there's just one more to go with homework 20, which I think is solving more Trig equations and a little more complicated. All right, see you all on Monday.